Hello everyone, I'm Alfian and today we are going to solve the Hackerrank challenge on the problem solving section called the electronic shop. And for this particular challenge, we are tasked to find the combination between the keyboard price and with the drive's price that is still below the budget. They already determined budget right here. Already declared budget right here, and we need to find the maximum nearest possible near the budget. And for the description, it says a person wants to determine the most expensive computer and computer keyboard and USB drive that can be purchased with the given budget, given price list for keyboards and USB drives and the budget. And the keyboards, both keyboards and drives, are in a form of array, so it's a price list of $40 and $50 and $60 respectively. And find the cost to buy them, find the maximum possible combination but still below the budget allowance. If it's not possible to buy both of the item, then we can simply return -1. And I am using, for this particular challenge, I am using the JavaScript since we don't have any TypeScript in the dropdown right here. Then for the function right here, get money spent, that takes the parameter of keyboards array and drives array and the p, which is the budget, and then we can simply return -1 as the placeholder right here. And then for the example right here, the example case, the person can buy a $40 keyboard. It's not 40 keyboards in unit, but $40 keyboard in terms of price, and added by the $12 of USB drive, which is equal to 52, and it's considered one of the nomination right here, or a 50 keyboard, which is the index of 1 with the $8 of the USB drive, and it's also the index 1, and the result is $58, and 58 is the one that wins the nomination because 58 is near to the $60 budget right here, and because the latter is the one that has the expensive option. And for the return integer in a form of integer from the function right here, the maximum that can be spent, or -1 if it's not possible to buy both items. So we can declare the maximum possible budget, then we can declare it as -1 as our initialization value right here. And then for the return, we can simply pass in our variable of the max possible price, or the combination of both keyboard and USB drive. And for the sample input right here, it says we have $10 of budget, and 2, which is the length of the keyboard array right here, and then 3, which is the length of the USB drive price list array right here. And the sample output is in a form of integer 9. Why is it 9? It's because it found the best possible combo that near the $10 budget, which is index number 1 and the index number 2, 1 and 8. And so without further ado, let's implement this. For this particular challenge, I'm going to use the binary search algorithm for the second array, which is the drives array, and I don't have to mind about the keyboards array to sort it because it's going to end up like the same thing, except it takes a processing time, which is unnecessary for our implementation right here. So for the binary search algorithm, you should modify or mutate the drives in place using the sort. The binary search requires us to sort the array before implementing the actual binary search, and then we are going to sort it in ascending order, or from the least value to the from the lowest value to the highest value. And then we can use the for loop to iterate our keywords array right here. And using the for loop, let I equals 0 as long as the I is below the keywords dot length. And then we are using the I++ right here. And so inside the keyboard iteration, we can define our initialization variable we can prepare the variable for the binary search of the drives array that we already sorted right here by declaring our let candidate is the candidate value, or the best candidate of the drives price, combined with the current iteration right here from the keyboards array of the current element. And then for the next one, we can declare the start point, then it's a 0. And then for the next one is the endpoint. The endpoint is equals to drives length -1. Let me remind you again that since we are operating on array, then the length, let's say the length of the array is 3, 5, 2, and 8. To get the last index of the array, which is the end point right here, then we are going to length -1, and its length is 3, and then -1 is equals 2. 2 is the last index of the array right here. And we can use the while loop to loop through the start point as long as the start point is below or equals to the end point. If it is, then we can declare our middle point using the let middle point, and we are going to find the middle point using the start index, and then added by the end index or plus end index, and then divided it by 2. Since we are, let's say if we have an even number of elements inside the array, and then the middle point would be pointing to between the, let's say if we have 4, or the length of array, let's say if we have drives array that equals to 5, 2, and 8, and 10. Let's say we have the length of 4, and then the start index will be 0. The start index will be 0, and then the end index will be 3. Why is it 3? It's because it's starting from 0, 1, 2, and 3, and it's already determined from the end variable right here. And then to find the middle part, of course we are going to add 0 plus 3 and then divide it by 2. Let's say if it's an even elements of the array, even means like it's 2, 4, 6, and 8, and so on and so forth, and 3 divided by 2 is of course equals 1.5, and then we need to somehow make this an integer to find the index of the middle part, which is 1. And so to find the middle part, we can use the JavaScript Math.floor, and then we can find the middle part. Since it's 0 and 3, the middle part is of course 1, index 1, it is equals to index 1 right here is 2 right here, the element number 2. And then of course we are going to determine our sum variable to sum the current iteration of the keywords I, because we are iterating the keywords array, keywords I with the of course the middle part of the drives array, the middle index. And the binary search algorithm, it's like slicing an array. Let's say if the combination of both keyboard price with the USB drive price of 2 right here is still above the budget allowance or the B. If it is, then we are going to eliminate this. And also let me tell you one more again, because we already sort this. I forgot to sort the array first. 5, 8, and 10. And since we already sorted, and the index 0 is 2, and the last index is the end index is 10, and then the middle part is 5. And then we can, from the first iteration right here, from the current iteration of the for loop right here, the keyboard price of the current iteration added by the 5 right here. If both of the prices of both of the combo is still above the budget allowance right here, then we are going to eliminate 5 from the nomination right here. And also, since we already sort the drives array, then we can, of course, 5 already out of the nomination, out of the candidate, and then of course we are going to eliminate the 8 and 10, or anything that after the 5 and after it. And then we are already eliminating it, and then we need to continue our while loop iteration to calculate the current iteration of the, still on the same iteration of the for loop right here, added by the 2, and then to check if it's still above the budget. If it's still above, then we are going to stop the while loop, because the start point and the end point is already on the same index, and the endpoint, since we are removing from the middle part, and then endpoint will be shifted again to beyond or below the start point, and then the while loop will stop. And then we continue the for loop iteration to count the next keyboard element, let's say index 1, and then we can simply pass in at an if check. If sum is above the budget allowance, if it is, then we are ultimately moving the end part to the end part equals the middle part minus 1. Else, if the sum of the middle part with the current iteration of the keyboard's array is still below the budget allowance, then we can simply assign the candidate. We can simply assign the candidate with the middle point of the drives array, or the middle index of the drives array, and we accept this 5 if the 5 combined with the current iteration of the keyboards is still below the budget. And then we ultimately moving the start point or the start index to the middle point plus 1. Let me explain the binary search algorithm and visualize it so you can get the better idea from this. Let's say if we have an array of already sorted 2, 5, 8, and 10, and then we have a keyboard array represented by K, keyboard array of 20, 30, and 40. And then we have the budget of, let's say the budget is 30, and this is the keyboard array. This one is the already sorted drives array. Let's rewrite this. And so can now declare our start index right here. And of course you guess it, with the end index right here. Since the start is always starting from the index 0 and the end always starting from the end index right here, which is the length of the drives array -1. Then to check for the first iteration, which is 20, check if 20 plus the middle part, which is 5. Then let me remind you again to find the middle index. Find the middle index right here. We have to, using the Math.floor of the start index added by the end index and divided by 2. And then the start index is equals to 0 and the end index is equals to 3. And then it's, of course, it's going to be 1.5, and then Math.floor, in the Math.floor is equals to index 1. The index 1 is 5, and then of course is if 20 plus 5 is above the budget. If it's still above the budget, then we can eliminate the middle part by moving the end point or the end index to the middle part -1. Moving the index right here, since we are using the while loop, and we are moving the index right here. The middle part right here, -1. And I forgot to include it, that we are still inside the while loop, while start is below or equals the end. And then the if else is inside the while clause right here. And then we can add the check if the combination of keyboard and drive price is below the budget, using the else clause right here, then we are going to move the start index to the mid +1, the opposite of the one that the index right here. So let me reiterate this again. Let me reset this. Check. To check, let's say for the if check right here, let's say if the budget is below the 25 right here, then we can execute the operation right here, moving the end point to the middle part -1. Let's say if it's still below the budget of the 30 right here for the first iteration, since 20 plus 5 is equal to 25, which is still below the 30 budget, then we can move the start index to the middle index +1. And why middle index +1? It's because the 20 plus 5 is already calculated and it's returning 25, so we have to calculate between the 8 and 10. So that's why we are using the binary search algorithm, and we already sort the array and check for another scenario to check if the budget is equals to 25. Let's say it's 24. Since let me reset again. 20, the middle part is 5, and of course we are moving the middle part, or the end point to the middle part -1 right here. And then we continue our while loop iteration. If it is 30 or above the 25 and is still below the $30 budget, of course we are moving the start point to the middle point +1 right here. and eliminating all of the 5 right here. And we are not going to look after the look over the 2 and 5 to the drives iteration, right? Because they both already eliminated. The same thing goes if the calculation of the iteration right here is above the budget allowance, then of course we are going to move it right here, and we are eliminating the 5, 8 and 10 out of the consideration right here. And so let me go back to our implementation, and we can add a final check outside the while loop to check if the candidate is not strictly not equals to -1, is no longer -1, and the combination of keyboard price of the iteration with the candidate is above the max possible, right here, max possible array. And why I am adding the if check right here, to check if the candidate is no longer -1, which is already declared right here from the else, because it already found from the while loop iteration right here, already found the best candidate from the combo of the keyboard and the drive price, and check if the keyboard price of the candidate with the candidate right here, to check if it's above the max possible or the max possible variable right here of the current for loop iteration for the keyboard's price combined with the while loop right here of the drives, all of the drives price with the current for loop. If it is, then we can declare the max possible, assign the max possible value with the current keyboard's price of the current iteration plus the candidate. And then to visualize our implementation right here, we can move to our, let me move this to a new one, can add this one. Okay, so to visualize this, let's say if we have the array of keyboards array of 40, 50 and 60, and then the drives array of, let's say it's not unsorted, let's say it's unsorted with the 8, 10 and 5, and the budget is of course 60. And then of course we are going to sort the drives array by from the lowest to the highest, which is like this, going to be like this. And then we are declaring our part for the S in short, S, and then the E, then it's for the binary search algorithm. And we are going to iterate the keyboards array right here. We know it's 40, and declare our candidate right here, candidate -1, candidate -1, start index, which is 0 right here, we already declare right here. And for the end index is the drive dot length -1, which is the end index of the drives array. And while start is still equals or below the end, and then we declare the middle index. Let me resemble this as mid or M, the index, the middle index. The Math.floor of the start is 0, and the end is 2. 2 plus 0 is 2, divided by 2 is 1, and using the Math.floor of 1 is still equals to 1, and 1 is the index of is the index of the element 8 right here, and then we calculate, we sum the current index, current keyboard index, which is 40, plus 8 of the drives array of the middle index right here. Check if the sum, the 48, is above the budget elements. If it is, then we are going to move the end point or the end index to the mid -1, which is 5 right here. And then since it's already mid -1, then we can continue our while loop, because it's still, the start point is still the same or below the with the end point right here, or the end index. And then we can continue the iteration of the drives array, and since it's already pointing to 5, and then we can, of course, we are not going to declare we are not pointing to the mid because it already pointed to the 5. Both the start and end are already pointing to the 5, and then of course we sum the current keyboard index, which is still 40, with the 5 to check. Oh, I'm sorry. So it's about let me reiterate this. It's 48 is above the budget, which is 40, still below the budget. 48 still below the 60 budget right here. And of course we are going to enter the else right here, and for the else clause we are going to assign the candidate variable to the with the middle index of the drives array, which is 8 right here, and the candidate will be changed to 8. And then of course we are moving the start index to the middle index +1, moving to the middle index +1 right here. And then we are continue the iteration, because since the start and the end index is still the same, and it fulfills the while loop right here, so we are going to iterate the while loop again. And of course they both pointing to the 10 right here. Of course we are going to skip this part to save the time, and then the sum, of course it will be 40 added by 10 to check if it's above the, if the sum is still above the, if the sum is above the budget allowance right here. Since it's 50, then of course we are going to the else clause right here. We assign the candidate to the drives with the middle index of the drives array, because we already skipped this of the mid index that already declared right here. I forgot to move it to here, move it right here to the 10. Of course the candidate will be pointing to the 10 because the drives array and it's the middle index is pointing to the 10. Of course the candidate is equals to 10, and then the while loop is already satisfied, and then the already satisfied because the start point is pointing to the middle index +1, to the pointing to the middle index, which is already 10, and then +1, and then +1 is out of bound, and the start index is nowhere to go, and the start index already surpassed the end index. Then the while loop stops, and we are going to continue our iteration to the next element of the keyboard index right here, which is 50, and then 50 for the next iteration. Then we reset the candidate. Before we reset the candidate, I forgot to mention to assign the max possible, from the if else that I already mentioned right here, to check if the candidate is no longer -1, which it is no longer -1, and it's already equals to 10 from the previous last iteration of the drives array, with the first element of the k iteration right here, which is 50, and 50 from the 40 plus 10, and then and with the and double ampersand operator right here, and the keywords, which is 40 of the current index, 40 plus the candidate, which is 10, is above the max possible variable right here, which is equals to -1. Since they both true, then we are going to assign the max possible with the 40 plus the candidate, which is 10, and the max possible of course will be 50. The max possible value is 50. Then we continue the 50 using the 50, and we are starting all over again, resetting the candidate variable to -1, and then resetting the start index to the 0, and the end index to the last index of the drives array again, and check using the while loop. It still satisfies because start index is still below or the same, and the end index is still the same. Since it's still the same, then we are declaring the middle point to the 8 right here. Do it all over again, and summing the 50 with the 8 right here, which is the middle index, with the 8, 50 plus 8. Check if it's still above the budget. Of course it's still below the budget, then we are moving to the else clause right here, and the candidate is equals to the middle index of the drives array, 8. We got 8, and then the start, moving the start to the middle plus 1, and we continue our while loop again, and then we define the middle point to the 10, and then we are summing the 50 with the 10, and then to check if 50 added by 10 is equals to budget, which is still below the budget, and of course we are going to move it to the else clause right here, and then we are moving the current candidate, assign the current candidate to the 10. Is the one that pointed on the middle index right here, which is 10, and then we are moving the start index, the start to surpass, to out of bound, beyond the specified drives maximum index right here, and then we don't have to use the while loop again because it's already, the start already surpassed the end index, and of course we are going to check if the candidate is not equals to 1. Of course the candidate is not equals to -1, and it's this one is already true, and then check, and checking if the 50 plus 10 is above the max possible, which is 50 right here. Since it's 60, and it's a true because 60 is of course above the 50, the max possible right here, then we are going to assign the max possible with the new one, which is 60, and then we continue our for loop iteration right here to the 60 right here, and to check the 60 and doing all over again and checking if the sum of the keyboards of the current keyboard price, which is the $60, plus the any of the drives array right here, since it's already 60 and no longer suitable for the budget already, and no longer suitable to have a combo with the USB drive price, then of course we are stopping the iteration, and then the candidate still lives to -1, and then the candidate will not pass the if check right here, and the max possible will stays 60 right here, which is the 50 added by 10. So that was a lot of explanation from me. So let's return this to see if it works, and of course it's working. And let's submit our code to make sure if all test cases pass. And congratulations. Okay, so that's about it. I hope you understand this video. If you still don't understand, you can ask me in the comment section, or if you have any better solutions, you can also write in the comment section. I hope you have a great day, and I will see you in the next video. Goodbye.